Intel EP, which is the 2-socket chip, running the range of about 3 gigahertz at top speed, 3.3. Looking at the new EX Nehalem with the 8 cores, right now their top clock is 2.27. About being able to clock this at twice what Nehalem's doing, okay? I have to warn you, they're shipping boxes that they've clocked up to about 3 gigahertz with the EX, their ARC910s. Be cautious of that. Intel doesn't support that. The cool thing is there's a chip on board the Power 7 that monitors power, monitors heat, monitors the performance of the chip continuously, okay? There's a lot of cool stuff on here that the mainframe guys put on to monitor everything that's going on. But one of them is it monitors the temperature. If the temperature gets too high, if it starts getting really hot, if you're pounding the heck out of this and it starts getting really hot, the system will automatically throttle back the processors to cool it down. So you don't have a failure based on heat. The converse of that is, if it's not run very fast, not very heavily, and you're not using it all, the system will automatically clock it up by as much as 10%. It will actually overclock the processors by as much as 10% if you're using them. Okay. So you don't actually have to go to turbo mode to do this. Just let the thermal management device monitor it for you, and it will automatically turn it up for you. Okay? In an overclock situation, for instance, if the chip is only running at about 3.1 gigahertz, it will overclock to 3.3. If it's running at 3.5, which is one of the larger boxes, it'll actually overclock it to 4. So if you're not pounding away at your box, the system will automatically turn up the clock for you to get better performance. Pretty stuff that goes on inside here. You won't see this from Intel for a long time. So the Power 7, now this is basically a small 2-socket 16-core Power 7. 4 sockets in it, make it a 32-core in a 4U enclosure. This Power 7 runs more than twice as fast as anything else in 4 sockets out on the market today because of those kinds of features. In fact, if you get up to the really big stuff, this is the 4-socket, go to 8-socket, go to 32 sockets, which is the Oracle Microsystems M9000. Has 128 cores and 32 sockets, and the 4-socket 32-core box Power 7 is almost as fast as the 128-core M1000. Top box that Fujitsu is shipping for Oracle right now. I'm not even saying the word sun anymore. I'm trying to understand. Sun is gone. Okay? Virtualization. This is the cool part. This is where IBM really shines. Virtualization that's on the IBM box was designed by the same guy who designed VM on the mainframe 30 years ago, and they designed Prism, which is their hardware partitioning, on the mainframe 20 years ago. He came in 10 years, 15 years ago, and designed the hypervisor for this power box. So it works a lot like the mainframe. What do you do that? The beauty of that is it's a little tiny piece of firmware. It's not an operating system, which is what VMware is. VMware will tell you it's a down Linux operating system that runs on top of the hardware, and then it runs against the guest operating systems that go through that Linux operating system to get work done. Okay? That's vSphere. Well, you're not talking about vSphere. No, I'm talking about vSphere. Actually, ESX 4.0. And the advantage of that type of a hypervisor is overhead. You turn on VMware, you run a single virtual machine, it costs you about 10 to 15% overhead just to run a virtual machine. As you put more and more virtual machines on with more and more resources to support, that overhead could be as much as 40%. About 40% of the utilization of the box just to get VMware. Now, not a bad trade-off if you're doing Windows. No question about that. You can't do Windows virtualized any other really good way. Quite a trade-off if you want to do Linux and you have a better way to do it, or Unix. What virtualization give you? Flexibility, we talked about that, and utilization. Let's see how it works. Here's what IBM did. They designed the hypervisor and the hardware at the same time. As a result, with VMware, and I'll use that as my example, but it's the same thing with Hyper-V, it's the same thing with Zen, Windows, those Intel-based virtualization systems, you have one single physical CPU as one virtual CPU. It can't be any other way. Okay, you can have two physical CPUs as a virtual CPU, but that doesn't make a lot of sense. So it's single CPU based. With IBM's Power 7, we can slice a single CPU into 10 separate virtual partitions. So you can actually have a tenth of a CPU as a full virtual partition with a full operating system running on it. Now, we don't recommend that be one of your choices. But see, we're discovering that 2/10 of a Power CPU is a lot for instance, a developer. We have a lot of developers we run on 2/10 of a CPU. Okay? A lot of UC guys can run on 2/10 of a CPU. The other thing is you can use a 1/10 CPU as a heartbeat for clustering. And we do that a lot. You can have either dedicated CPU, so you can say this partition is critical. This is my Sybase ASE partition. It needs 4 CPUs. Give it 4 CPUs. And you take all the rest of the CPUs in the box and you slice them and dice them and use them for other stuff like test, dev, QA, applications run against the Sybase, whatever you want to run on that. So the advantage of being able to basically share the CPUs, we can now do the same thing with memory. Remember I talked about, well, let me show you. So we slice and dice this up. We have production workloads, box, and test, dev, and QA. This is because these partitions are NSA, National Security Agency, certified for the highest level of security that they have. So when your auditors come in and say, well, you can't run all that on the same box, actually you can't. It will pass an audit. Okay. The other thing is that if I'm running this thing with production and test, dev, and QA, and all of a sudden my production spikes, and I have more performance, the cool thing about this technology is I can move these CPUs and memory around anywhere I need them. So if I got one partition that all of a sudden spikes, my production partition that spikes, and it's running with 2 CPUs and it needs another half a CPU, I tell the system, this is my highest priority partition, go get a CPU from somebody else and put it on here. And do that. Around for you automatically based on workload, based on response time, based on throughput, whatever you want to base it on. Or you can get in the console and do it yourself. And same thing with memory with Power 7 now. Okay? The other cool thing is, if you don't have enough CPUs, who do you think it goes and gets the CPUs from? These guys, right? The test and QA guys, it just goes and gets some of their CPUs and puts them in production. That spike might only last a couple hours for a batch job. It lasts a day for end of month closing or end of year closing or whatever you need it for, right? So you just run for that period of time, and then when it's done, you give them back. Make the developers mad? Sure, but you know what? Right? Just don't take the day off. And the cool thing is we can now do the same thing with memory. We talked about memory expansion. We also have memory sharing. So we can take the memory in the box and share it among all the different virtual partitions in the box. And you can move it around. So if one partition starts running short of memory and it's a critical partition, you tell the system, give this guy first priority on any memory that's out there. So it goes and gets it. Now the other cool thing is we put spare capacity in these boxes. We always ship the boxes with more CPUs and more memory than it needs. Now, you don't pay for it until we turn it on, but we put in there. You pay iron. I guess it's not iron anymore, is it? It's silicon and gold. You pay for the silicon and gold, and you know gold's expensive, so expect to pay a lot for that. We put them in the box, but you don't pay to use them until you turn them on. And the cool thing is, IBM will let you do that by day. In fact, one of our biggest customers running power is Bose up in Boston, you know, the speaker guys. The world upside down for Bose. They locked the systems down in September, and October things start to crash, start to go crazy. Black Friday is overwhelming for them. It runs like that through January when they do all their returns. I get the retail territory. We have 64 cores inside their box. They use on the average about 30 to 32. October, November comes, and all of a sudden things spike. We start turning on CPUs. Still have the same response time, still get the same throughput. When January comes, we turn them back off again. We go back every quarter, and we see how much they use, and we bill them for that. Nobody can do that. That's mainframe kind of stuff. The cool thing is, if you're in that mode, we can also allow you to intermittent it and charge back for memory, charge back for CPU cycles, kinds of things that mainframe guys do. And the key is we can consolidate all this onto a single AIX box or a single Linux box out outpace what they can do at VMware significantly. VMware is limited to 8 virtual CPUs in a single partition. It's limited to 1,000, give or take. Now, we don't have